Hello, so this is a YouTube video for anyone who got a 3D printer kit or a 3D printer and they have it assembled and they can't get it working. I've been working on mine for about a month now, at least it's been 3 weeks, and I finally today got to print something. It's just a basic calibration pyramid. This was a pain in the butt to print because I had to go through so much troubleshooting, calibration, whatever you want to call it, to get this thing to work. It's a pain in the butt, and if you're watching this video, most likely you've already experienced how painful it can be to get a 3D printer to work. So I'm just going to go through all the things that no one else really talks about, and I'll get your printer working. So the printer I have here is a PrinterBot Junior, and I got it as a kit. I assembled it in about 2 days. I had it assembled, and then from then on to today, which has been about 3 weeks to a month, I've just been troubleshooting, calibrating. I had some missing pieces too. I got those shipped in, and etc. So the first problem that most people have with these 3D printers is the extruder isn't working. So if you notice, the extruder is the main part of the whole printer, and it's covered by this red sheath. It's to keep the heat in. It's basically an insulator. And in the instructions, when I was assembling it, they never really explained the importance of this tension screw right here. So I'm going to tell you that this is actually extremely important. At first I was wondering what the heck is this for. I just had it hanging off in the side like that. I really didn't understand. And then it turns out this actually allows the plastic to get fed in. So basically, there's a bearing ring, and then the plastic goes through into this small hole down there. And then behind it is this little what they call it, a hobnob or something. And basically it has these little teeth in there that latch onto it. So before, when I had it, I really didn't understand what this little tension screw thing was. I had assembled it like the instructions said. The instructions never explained how to use it. So I basically was just having it like this, and it wasn't printing. The plastic wasn't coming out. And the reason why the plastic wasn't coming out was because the plastic wasn't being pulled in hard enough, and in order for it to be pulled in, it has to have a nice tight grip. So to do that, you actually have to set the tension on these. You're going to hold this with some pliers like that. You're going to screw it in, and I have about 1/4 of an inch sticking out at the end. I think that's pretty good enough. Then you're going to feed the plastic through in between the screws and between this while it's hot. For PLA, which the PrinterBot Junior uses, it's going to be up 190 degrees Celsius, and for ABS it's going to be 210 Celsius. So you're going to feed it through there, and then once you're pushing it in, it's going to actually show up on the extruder. It's going to start dripping out. And right now it's not hot, that's why I can touch it and not burn myself. You have to feed it in and push it, and once you see the plastics coming out, you know it's working. And what you do then, this is what they actually failed to explain, was you're gonna pull this, and these little springs are gonna get tension, and then you're gonna put it over the wood. So it's gonna go, and then it's just gonna stay and sit flat. So you see how it's just sitting there flat now? It actually went over the wood piece. So this is something that once I fixed, I actually got the extruding properly. Something that I never really explained in the instructions. The thing is, you actually might have to clean out the extruder. You might have some burnt plastic, like you were tweaking with the temperature. You really didn't know, why it wasn't extruding, so you might have turned up the temperature like I did, and I actually burned some plastic in there inside the extruder. So I'm not going to actually go through how to clean it out, but there is a really good video on it. And that's the video I use. It's really short. I'm going to put it in the description. Okay, so the next problem is the temperature. So like I said, for PLA, which is what I'm using here, this is like a bioplastic made from corn, you're going to need it to be at about 190 degrees when you're printing. Now, even though you set it to be 190, it might not actually be 190. The reason why is the way the temperature feedback works is that there's 2 sets of labels that go to the extruder down here. There's these 2 clear ones, which are the thermistor, and I'll explain that in a minute. And then there's a black and red one, which is the power. So the way it works is the thermistor tells the software on your host computer what temperature the device is and the computer tells the board in here how much power to give to the extruder to get the right temperature. So basically, what that means is, if it's set at 210, it's going to keep the heat, it's going to keep putting in power until it gets to 210, and it's going to keep it at 210. Well, the problem is, even though it says it's at 210, it doesn't necessarily mean it's at 210 degrees, or in this case, 190 degrees. So what you have to do, you might have to tweak with the thermistor, which is the temperature sensor. And if you're not familiar with electronics, all thermistors is it's a heat-sensitive resistor. If you still don't know what I mean by that, that means I can easily hack it to get it to work. Now, in my case, I actually didn't need to do it, but I did it just for a demonstration. So you're gonna in the printer bar, you're gonna have these two, this white and black wire coming out, which connects to the two clear wires down here. You're gonna cut either the black or white; it does not matter. Make sure it's from the black and white wire. Do not cut any of the other wires, otherwise you can damage them. Cut one of the black or white wires, then you're going to have to solder in a potentiometer. You're going to need a 1000 ohm potentiometer, and you're going to solder in one of the outer leads and then the middle lead. This potentiometer is a little weird looking. Most of them have 3 leads. You're going to center in one of the outer ones and then the middle one. And then you can actually tweak it by turning it, the potentiometer. In this case, I would put a screwdriver and turn it. And you can actually tweak it. So you also need a potentiometer to solder that in, and then you also need a temperature sensor. So you can get contact temperature sensors, which I prefer, and you're just going to connect it to the brass part. If you have a contact one, you're just going to touch it to the brass part under here and read the temperature. If you don't have one of those, you can get, if you have one of the infrared ones, these also work, but they're a little bit pickier. So these are basically point and shoot, and you can get the temperature. So my wall is 77 degrees Fahrenheit. And everything is going to be in Celsius for the 3D printing. So you're gonna, there's a laser up there, and this is the actual sensor. So you're gonna actually get this under, here, and you're gonna raise this up, and then you're gonna get the brass part to be right above here. You want to get as close as you can, read the temperature, let go, and then read it, okay? And then you want to make sure it's at the right temperature. This is a little trickier. You might not need to do it. So that's the temperature. So, but really the main problem with extruding is this little tension screw. If you get that done, I think it should be fine. And if it's not extruding the plastic, you might have to change the temperature by 5 degrees Celsius each time, up or down, and then see how it works. You also want to make sure the plastic is free to move. What that means is that there's nothing pulling the plastic back. So I just have it on the table. There's nothing really holding it back. There's no weird knots or anything, or nothing pulling it back. So you want to make sure that's true. I want to get a spool because it's just sitting on the table. It doesn't really look that neat. Okay, the next problem most people have is that the axes are not moving freely. So you have 3 axes, okay? So I'm just going to go over which one's the X, Y, and Z. They don't really explain it too well in the instructions which one is X, Y, and Z. The X-axis is this one. It's going to be the one that goes side to side, okay? And the motor for that is down here, okay? The Y-axis is actually back and forth. It's this one. It's going back and forth. The Z-axis is going up and down. Now that's a little bit harder to move. Can't really show you too well because you get to sort of tweak this little rod. Okay, basically Z is up and down. Y is back and forth, and X is side to side. So there's no negative numbers. This is your origin. This is going from 0 to whatever number in X. This is going from 0 to whatever number in Y, depending on what printer you have. It's going from 0 to whatever number I have on Z. Okay, so I just want to clarify that. The main reason it might be not moving very freely, so I'm just going to show you how it's supposed to move. I'm just going to open up the software on my computer, and then I'm just going to move it around a little bit. So I'm just going to move the X-axis a little bit. Okay, that's the X-axis. This is the Y-axis. And this is going to be the Z-axis, which is the slowest one. So it's just moving up a little bit. Okay, so I'm just going to home them all, and this is going to go to the origin, okay? Okay, now it's at the origin. So it's like, the extruder is like about the width of a piece of paper above the bed. And the bed is going to be this little board. I covered it in this blue painter's tape. Highly recommend you do that. Coat about 2 or 3 layers and you'll be good. So if yours isn't moving as smoothly as mine did, and remember the z-axis is going to move a little bit slower, if it's not moving as smoothly as mine did, there's a few things that could be wrong. One thing is that you probably did not set the, you notice there's actually belts in here. So this belt, it goes under the ball bearing, over the coupler, and then under again and out. Okay. I want to make sure that the motor and the bearings and everything are in good contact. There's nothing stopping them. The way to do that is to actually get a Sharpie, and there's a little bit of exposed metal right there. You're going to make a tiny little dot on the very edge of the metal. Okay, let me try to make it a little bit bigger so you can see. There. Now, I'm going to move the y-axis, which is this axis, but you can put this on any one you want. It's going to be a little bit harder to do with the X, but for the Y, it should be pretty simple. So, you're just going to move it, and then you're going to notice that the black dot moves with it. See? So if your black dot's not moving like that, that means that the coupler isn't tightened properly onto the motor's shaft. So you're going to want to do that. Okay, so another reason why it might not be moving freely is that there's something lodged in these linear bearings. So you notice in the printer bot there's 4 linear bearings, and then each one has a rod. Every pair of them has a rod running through it. There could be something lodged. To do that, you're going to have to unscrew this assembly, take it out, take the rods out. You wipe it down with a cotton cloth. You don't want to wipe it down too hard and get the grease off or anything. You want to look through those little linear bearings and make sure there's nothing in them. That could be just a simple problem, not really too hard to solve. So another problem I had when I first started, and this one really pissed me off, was that it was moving in the wrong direction. And I didn't know any better because I didn't know the X, Y, and Z at first. So what was happening was this axis all the way over here, and the motor just kept spinning. It would go. Oh, let me show you. It would do that, and then it would just keep pulling. You could hear the motor kind of screeching and moving and trying to move it over there. The reason why was the y-axis in the printer bot Junior, and maybe some other models too, is actually wired backwards. So if you see here, this is coming from the y-axis. I put it backwards, so the blue wire is coupled to the red wire, and same here. So the y-axis is backwards. What's happening is when you hit the home button, this is supposed to contact the end stop right here, and it thinks the motor's supposed to go this way, but it's actually supposed to go this way. So I'm just going to home. I'm going to click the home button for the Y, and you're going to see what it's supposed to do. It's supposed to do that. And then when it hits it, it's supposed to stop. So you have to put it backwards because for some reason, it's just like that. And the Z-axis, okay, in the instructions they really didn't go too thoroughly. They kind of did how the Z-axis works because it's a little different than all the other axes. So in the Z-axis, you have this threaded rod that's coupled with the motor down here with a piece of vinyl. This is pretty simple to do, it's not really complicated. What they really didn't explain was that in here, there's actually going to see it from the top. Okay, there's a little nut down there. Let me get something. Let me grab it. Right there, there's a little nut down there. That is actually screwed onto the rod, and that stays inside this little wooden assembly. So when the rod spins from the motor, it forces the nut to go up and down, and then the rest of the assembly follows it going up and down. Another thing is you have to calibrate it. What that means is you want to make sure that the extruder is at the right height off of this. You want to make sure that it stays the right height when it goes to route. You want to make sure that, you can lock this and everything. I'm not going to go too much over that because it's already been done and done really nicely. So I'm going to put a link in the description on how to calibrate your 3D printer. You can skip through some of the beginning parts, but he does a really good job with that. And this is with the printer by Junior. I don't know about other 3D printers. The motor placement was really confusing. So when you get if you get the kit, you're going to get 2 types of motors. You're going to get one of these big motors. Okay, they're all separate motors, but the size is different. You're also going to get these smaller separate motors. Now, in my kit, I got 3 small ones and 1 big one. And I was confused where the big one goes because they never really explained. They just said, put the Kaizen motor. Well, they all say Kaizen. That says Kaizen, and this says Kaizen right here. So they didn't really explain that. Here, I'm going to explain it to you right now. In reality, you actually need 2 big ones and 2 small ones. The 2 big ones, the one big one's here. And the reason why is the big one actually has a little notch on it, and that lines up with this gear. The other big one goes down here for the x-axis. because I actually had the small one on the x-axis and it burned out, and I had to get a new big one, and they sent me that on a replacement. So if you get, so that actually was the reason why mine was jamming. But yeah, the two big ones go here, and then the small ones go here. There's going to be one small one right here. The other small one's going to go for the z-axis on there. So this is a printer by Junior. Your printer may vary.